Hey guys, welcome back. We now know how to load a dataset in Pig and how to project and manipulate columns in Pig. All the columns we have looked at so far are simple data types like int, float, etc. But Pig can support data types which are complex and nested as well. In this lesson, we'll learn three complex data types in Pig: tuple, bag, and map. So take a look at the instructions right here. First, we are loading our stocks dataset. Then we are filtering our stocks dataset for year 2003. So filter by year will only have records from the stock dataset for year 2003. And then we are grouping the filter by year relation by symbol. So let's execute the instructions one by one. I'm already in the grunt shell, so let's load the dataset first. Stocks is now loaded. Let's go ahead and filter the dataset only for records 2003. There you go, that is done. Now let's do a group by symbol. Okay, the records are now grouped by. So now I want to project some records from group by symbol. But before that, I wanted to see the description of group by symbol to see the structure of group by symbol. So let's do a describe on group by symbol. So I've copied this output and here is the formatted output. Now it is very easy to interpret this output. Let me give you a couple of tips, okay? How you can identify a tuple and how you can identify a bag. Whenever you see a parenthesis, that means it's a tuple. So in the below example right here, you see an opening parenthesis and a closing parenthesis. So which means this is a tuple. And whenever you see a curly brackets, which means it's a bag. So in the below example right here, you see an opening curly bracket and a closing curly bracket, which means this is a bag. So now you know how to identify a tuple and how to identify a bag. But what is a tuple and what is a bag? Tuple is nothing but a row. But what is a row? A row is a collection of columns. As simple as that, right? What is a bag? A bag is a collection of tuples, which in turn means it is a collection of rows. So you can very well derive bag is more like a table because table is a collection of rows. Makes sense, right? So if you look at this example right here, that is the bag illustration, you know this is a bag because you see a curly brackets. And also by definition, bag is a collection of tuples, and you can also see in this example, you see a collection of tuples inside a bag. And how you can tell it's a tuple? Because you have parentheses right here. Make sense? Now let's get back to the instructions. Now let's go back to group by symbol. From the curly brackets, we know group by symbol is a bag. Then it should have a collection of rows or tuples, right? By looking at the definition, it looks like group by symbol has two columns. First column is named group and it is of type character array. And the second column is interesting. It is named filter by year and it looks like it is a bag. And a bag by definition will have rows or tuples. The first column is oddly named group. Why is that? It refers to the grouping column. In our group by instruction, we are grouping the dataset by symbol, and hence the group column refers to symbol. So in group by symbol, each row, that is a tuple, will have a symbol and a collection of records for that symbol. Let's output the top 10 records from group by symbol. So I'm going to say limit 10 equals limit group by symbol 10. And I'm going to dump the results of limit 10 on the screen. This, of course, executes a MapReduce job. So let's wait for the output. So here is our top 10 records for group by symbol. And here is a sample formatted output for better readability. As you can see, the grouping column, which is the symbol, and the rows are grouped together. So CASC is a symbol and you have a bunch of records for CASC grouped together. So we know group by symbol is a bag, which means it's a collection of rows. There you go. You see a row here, and there will be many more rows. This is just a sample formatted output. And the second row, as you can see in group by symbol, in this formatted output is for symbol CATO. And the second column here is a bag, which is nothing but a collection of rows for symbol CATO. The other important thing to note here is how filter by year, which is a bag, which is inside group by symbol, which by itself is a bag. So a bag inside a bag. And that is nesting, and that is totally legal in Pig. You can even have a bag inside a tuple. You can even see that in the formatted output right here. So here's a tuple, and you can see a bag inside a tuple. You can see a curly brackets here, which means it's a bag. And this bag is inside this tuple right here. Make sense? And let's now see how to project the columns from group by symbol. Take a look at this for each instruction right here. Always refer to the description of the relation you're trying to project. That would make it easier to understand the relation first and then makes the projection much easier. In this instruction, you're saying for each record and group by symbol, project the group column, which is nothing but the symbol, and close price column from filter by year. You'll be using the dotted notation to reach the closing price since it's inside filter by year. So the close column is right here inside filter by year. So if you want to reach any of these columns, you have to say filter by year dot close or filter by year dot symbol, etc. So let's run this instruction. And then let's do the limit operation again on the instructions so that we're not trying to display the entire output on the screen. So close by dump limit 10. So here is the output. Again, I have taken a sample output and I have formatted the output here for easy readability, right? So here in the output, we are projecting two columns. The first is the group, the symbol, and the closing prices for that symbol from the collection of tuples. Since we have grouped the records by symbol, you can do more meaningful aggregate operations like finding average, maximum, or minimum values from the group of records. So let's try to find out the maximum closing price for each symbol. So here's the instruction for that. Very simple, right? For each group by symbol, generate group max filter by year dot close. So this will give you the maximum closing price from this list of values right here. Make sense? So let's try this. All right. Now let's do the limit operation again. Limit 10, 10. And say dump limit 10. There you go. Here's the output, and it is the maximum closing price for that symbol. Okay. So now you can also group by more than one column. And here is an example. We wanted to find out the maximum closing price of each symbol by year. So the first thing we have to do is we have to group the stocks dataset by symbol and year. And this is how you do it. I'm using the getYear function here to extract the year from the date column. So here I'm saying group stocks by symbol and year. So let's run this. And also let's do a describe on group by symbol year. Here's the output. I have formatted the output right here. So as you can see, the group column now has two columns, the symbol and the year column, which is an integer. Now, the problem is to calculate the maximum closing price for each symbol every year. Since you have already grouped the records by symbol and year, here is your for each statement to do the projection. So you're saying for each group by symbol year, generate the group, that is the symbol and the year, and the maximum closing price from the list of records for this group. Make sense? Let's run this instruction. And let's do a limit 10. So here's the output. Now let's go back to the instructions. So if you have a closer look at group by symbol year, you can see this is a relation, and this relation has two columns. The first column is a tuple with two columns in itself, symbol and the year. The second column is a bag with collection of stock records. And now we have projected the first column, which is the group, which you can see right here, and then the maximum closing price from the group of records. And that is right here. And you can see the nested output here. You have a tuple and you have a tuple inside a tuple, right? You can actually break this down. You can even project individual columns and remove this nesting altogether. So here is how you project the individual columns. For each group by symbol year, generate group.symbol group.$1 to pull out this value right here. Since the year column doesn't have a name because it is a derived column, you're using the position of the column to get the column. And then you're saying max stocks.close. So let's try this instruction and let's do the same limit operation all over again. Limit 10. And there you go. If you see this output is not nested as the previous output. In the previous output, you had a tuple and you had a tuple inside a tuple. Since we have projected the columns individually rather than saying just group, like group.symbol and group.column from position 1, you don't see the nesting here anymore. It's a clean output. Now we understand what is a bag and what is a tuple. We also looked at these types can be nested and how to project the columns we need. Whenever in doubt during projecting columns, we looked at the definition or the description of the table or relation using the describe instructions to guide us through. Bags and tuples are types just like character array, int, float, etc. in Pig. And this means that we should be able to define our data set using bag, tuple, etc. Let me explain that. Let's take a look at group by symbol year relation again. What I'm going to do next is I'm going to store the output of group by symbol year into a file in HDFS. So let's run a store operator on group by symbol by year. So let's look at the store instruction. It is very simple. You're saying store group by symbol year into this location in HDFS. And if you don't specify the pig storage function with the delimiter, pig is going to by default store your data set in tab delimited format. And if you need to save your data set, for instance, in comma delimited format, just simply say using pig storage, comma, right? In this case, I'm going to store this data set in HDFS using the default tab delimited format. So let's copy this instruction and let's run this instruction in pig. The output is now successfully stored. So let's look at the output. So I'm going to copy this. I'm going to say Hadoop FSLS. And here's the output directory. So we have two files. One is success and the other one is from the reducer of the MapReduce job. So let's pick this one, Hadoop. And this file is the actual output. So I'm going to do a cat on that. And this is going to display the entire output. So I've copied a sample from this output and it is right here. So here is how each record in the output looks like. Okay, so this is one record. So now we have this data set in HDFS. Now imagine this. I give this data set to you and I'm asking you to load this data set and then find out the maximum volume for each symbol by year. It should be very simple if you know how to load this data set, right? Because the records here are already grouped by symbol and year. So if you are able to load this data set properly, you should be able to project the symbol, year, and the maximum volume for each symbol by year. Now let's see how to load this data set. Look at the load instruction right here. If you go back to the output, you can recognize that each row is made up of two columns separated by tab. The first column in this sample output is Dolce, 2010, and the remainder is the value of the second column. So first, let's break this down. How do you represent Dolce 2010? Looking at the parentheses, you should know that this is a tuple. So let's do this. We're going to give this column a name, GRP. And since this is a tuple, we're going to say tuple, symbol, and year, because this tuple has two columns, symbol and year. It is very simple. Instead of saying integer or float or character array, since this is a tuple, you're specifying the data type of the column as tuple. Now let's look at the second column. The second column is a bag. A bag is a collection of tuples. How do we know it's a bag? Because we see curly brackets. We're going to name the bag stocks_B and start with a curly bracket because it's a bag. Since a bag is a collection of tuple, we have to define the tuple inside the bag. And for the name of the tuple, we're going to say stocks_T. And then we specify the list of columns inside the tuple. Even though you're able to give a name for this tuple, that is stocks_T, you cannot refer to this inner tuple. And quite honestly, you don't have to. We'll see that in a second, okay? Let's run this instruction now to load this complex data set. Here you go. It is now loaded, right? So now going back to our problem, the data set is already grouped by symbol and year. All we have to find out is the maximum volume for each stock symbol by year. Since we have loaded the data set properly, it is a very simple projection. So here we are saying for each complex type, generate 3 columns. We want to project the symbol and the year. So we have to go like group.symbol and group.year. And then we have to say max stocks_B.volume. You don't have to go like stocks_B.stocks_T.volume, okay? Because I was saying you cannot refer to this inner tuple. So you can go directly stocks_B.volume. So let's try this. There you go. Let's do a limit again. Limit 10 equals limit. And then let's do a dump limit 10, okay? So when you see the output, it's going to look like this. So now we know what is a tuple, what is a bag. We also know how to interpret a tuple and a map. Not only that, given a data set with complex data types in it, we also know how to load the data set. Now going back to the third and the final data type, maps. Map is another complex data type in Pig. And map, as you know, is nothing but a collection of key value pairs. Take a look at this data set, for instance. So here I have a small data set to demonstrate maps. It is information about few departments in city of Chicago. Every row has 3 pieces of information: department ID, name, and address in semicolon delimited format. So the first column is the department ID, and the second column is the department name, and the third column is the address. We are more interested in the address column because it is a map. And how can we tell it is a map? Map is always represented using square brackets. The key and value pairs are separated by hash symbol, and each key value pair inside a map is separated by comma. So this is a key value pair. We know it's a key value pair because it is separated by hash, and each key value pair is separated by comma. So we have 3 key value pairs in this map. So this is key value pair number 1, this is key value pair number 2, and this is key value pair number 3. Loading a map is very simple. Look at this load instruction. You're saying Pig storage semicolon because it's semicolon delimited data set, and then the address column is a map. You're just saying map, open a square bracket and close the square bracket. That's it. So let's copy this and let's run this. Now this data set is loaded. Now how do we project elements or key value pairs from a map? It's very simple. You will use the hash qualifier. Now look at this project instruction right here. You will use the hash qualifier to project the elements from the map. So to project street, you will say address hash street. And to project the city, you will say address hash city. Because if you look at the data set, street is a key, city is a key, and state is a key. So when you use the hash qualifier on the key, you can pull out the value from the map. That's simple. So let's try this. There you go. Now I'm going to print the result set on the screen. Department address. Here's your output. We have 3 columns in each row: department name, the street address, city, and the state. That is it, guys. Let me summarize what we see in this lesson. In this lesson, we looked at 3 complex data types in Pig: tuple, bag, and maps. If you work in Pig, you'll see these data types a lot. So it is very important. You know how to spot a complex data type, and you also know how to work with it, like loading a complex type and projecting from the complex type, etc. With that, let's wrap this lesson. See you in the next lesson.